This is video assignment number 2 for chapter 13. And the question that we are given is, recent catalytic converters, in addition to reducing emissions of carbon monoxide and unoxidized hydrocarbons, reduce nitrogen oxide pollution. In a chamber filled with air, look up the normal partial pressures of nitrogen, oxygen gases, and dry air. At 2,200 degrees Celsius, the reaction that generates nitrogen monoxide from nitrogen gas and oxygen gas has a Kp of 0.050. What are the equilibrium partial pressures of the three gases in the above reaction after the reaction? So, first thing that we want to do is write the balanced equation. We are told that our product is nitrogen monoxide and that we get that from nitrogen and oxygen, the gas form. So that's N2 plus O2 equals NO. And then we have to put a 2 coefficient printed there to balance the reaction because we have 2 oxygen, 2 nitrogen. And then the Kp value we're given is 0.050. Okay. Then we are told to find the initial partial pressures of nitrogen and oxygen. For nitrogen, that's 0.7 and for oxygen, that's 0.21 atmospheres. And in order to find the equilibrium partial pressures of the three gases after the reaction, we can use the ICE table. And the first column is just the initial partial pressure, so we can just fill that in for what we found, that nitrogen is 0.7, oxygen 0.21, and we are starting with 0 for nitrogen monoxide. And then we have the change, which in order to figure out if it's a plus or minus, we just look at what we're using. We know we're using the reactants, so the reactants are going to get smaller. So we're going to subtract x from 0.7 and then 0.21 minus x as well, because that's the other reactant. And then we add x for the product, and we actually have to add a 2x because there's a 2 coefficient here in the balanced reaction. So now that we have those values, we can use this equation, which is just products over reactants, to figure out the equilibrium partial pressures after the reaction. So we just plug in directly as seen from the ICE table. We plug in N2 as 0.78 minus X, oxygen is 0.21 minus X, nitrogen monoxide as, it's 0.0 plus X, plus 2X, sorry, but that's just 2X, so just plug in a 2X squared, and don't forget the squared. Then we can factor this out, which is this right here. Oh, and I forgot to say this. We do equal this to Kp, and we were already given the value of Kp. So this whole thing is equal to 0.050. And then we're given this, and then we're going to simplify this down. And once we simplify this down, we're actually going to multiply it by itself to cancel this out. But in order to do that, we have to multiply it by the opposite side as well. So we multiply that whole thing by 0.050, and we get 0.050x squared minus 0.0495x plus 0.00819 equals 4x squared. We're just going to combine all of those together so they're all on one side of the equal sign, and that gives us 3.95x squared plus 0.0495x minus 0.009819. Now, in order to solve this quadratic formula, I put it into a quadratic formula solver, and that gave us a positive number and a negative number. And we know that we can't work with negative numbers. It can't be negative. So we use the positive number, which is 0.0396981. And what we do here is we can just plug this x into each of these individual problems to get the equilibrium partial pressures of the gas. So I did that down here, as you can see. Here's the N2 problem. It's 0.78 minus 0.0396981. That gives us 0.74. And then we have oxygen, which is 0.21 minus 0.0396981, which is 0.17. And then we have nitrogen monoxide, which is 0.00 plus 2 times 0.0396981. That gives us 0.079, and all of these are atmospheres of the pressures. So now that we have all of these, this is our answer. These are all of the equilibrium partial pressures that we have, and we can just plug them back into this table if that helps, but these are the answers.